Hi, I'm Joe with Neoti here at the Neoti Tech Center, and today is another Tech Talk. For today's Tech Talk, we're going to talk about load capacity per port. Now, what does that mean? Let's start with the basics. So when a video signal comes into an LED system, it usually comes into the controller via HDMI, SDI, DVI, some kind of way that the video gets to the controller. From there, it gets to the screen through Ethernet ports, right? And it's usually more than one port that's available on a controller. Usually they have about 4, right? Sometimes more, sometimes 6, 8, 16, but your typical has at least 4. And so they go through Ethernet cables, Cat 5, Cat 6, and it goes to a panel, right, in your screen. It goes out the port into a panel, and then from there it usually gets chained to other panels in the screen, right? And so what happens is you need to know what your max level of chaining is in that chain, right? So I can chain out to, can I chain out to 10 panels? Can I chain out to 40 panels before I need to go to another port on the controller? And how do I know that number? And how do I even start to calculate that? That's what we're going to look at today, the load capacity per port. Okay, so current DirectView LED systems have a load capacity limit of pixels per port. So how many pixels can that port drive? Okay, now the easy answer that's most common and most typical for everybody is the magic number of 655,000. Okay, 655,000 pixels per port is the most typical. There are some variables that can make that capacity number go up or go down, and we're going to look at what causes those variables, and we're going to look at the math behind how those variables even get calculated, right? So let's look at where 655,000 even comes from, okay? So when you have Cat 5 or Cat 5e or Cat 6, just regular Ethernet cable, that's 1000 base T cable, or 1 gigabit per second, right? 1 gigabit per second cable. So that's our first bit of data, right? That's our first number that we plug into the equation. Remember, it's number divided by number divided by number. The first number is 1 gigabit. Now, how do I write that out? Well, normally it would be a billion, right? That's a billion bits. That's what that means. So 1 with 9 zeros. But what we have is what's called an average usage rate, right? 1 billion applies if the world is perfect and we're in a vacuum and that cable's only like an inch long, right? The real world comes into play, and so to reach an actual perfect billion gigabits per second is not realistic, so there's what's called an average usage rate. The average usage rate is 93.6% of a billion, right? Which is 936 million, right? 936 million is our first number. So that's a constant. We can always plug that in because we're always using Ethernet cable, right? So 936 million divided by the hertz or the frame rate of your source video, right? So video coming in, right now, broadcast video and video from like Netflix that's streaming or video from your computer is typically mostly about 60 hertz, right? You could drive that up to 120, you can knock that down to 30, and you can knock it, you know, in Europe it's 50 a lot, you know, and there's 59.94, which is really close to 60. Whatever your frame rate is of your video, you plug that in as your second number. So for this example, we're gonna plug that in as 60, right? Because that's typical. And then your third number is actually the bit rate or the color depth of your video, right? If you don't know it, then it's probably 8-bit. It's probably 8-bit color depth video, right? So 8-bit video means there's 8 bits assigned to the color red, there's 8 bits assigned to the color green, and there's 8 bits assigned to the color blue, right? That means that you have to take, for that third number, you have to take 8 plus 8 plus 8, your bit count for each color. Bit count for red, bit count for green, bit count for blue. And you put that in. So 8 plus 8 plus 8 is 24. And so you add that in as your third number. So if it's 8-bit video, you've got 24. So 936 million divided by 60 divided by 24 equals 655,000, right? That's your number. Now, as you change things, if you go up to 120 hertz on your source video, then your output then gets cut in half. 655,000, you know, turns into about 325,000, right? And so what that means is you have to then half the amount of panels you can put on your chain for that port, which means for the screen that you've planned on, if you change from 60 to 120 on the source, then you have to now provide double the amount of Cat5 cables, Cat5e, Cat6, double the amount of Ethernet cables, and double the amount of ports. Now you can double the amount of ports by getting a controller that has more ports on it, but if you've maxed out that, then you can start to chain controllers together to add more ports into your screen. We have that ability. So if you would add 120 into that equation, take the 60 out, put the 120 in the middle, then you would see that that 655,000 gets cut in half. Alternatively, if you want to only run everything at 30 hertz instead of 60, then 655,000 actually doubles, and you can run twice the amount of panels that you normally would with the average 60 hertz. And so there's multiple ways to get things done in this scenario. There's multiple ways to drive different panels with different amounts. If you had a limit on ports and you can't get another controller, and you have to be able to drive that many panels with just a few amount of ports, then you can absolutely do that. But the compromise is you have to knock it down to 30 hertz. Okay, so back to the bits real quick. This is where some people mess up. So if they want to go 10-bit video, so you're going from 8-bit to 10-bit. Remember I said for 8-bit video, you go 8 for red, 8 for green, 8 for blue. If you go 10-bit video, you actually have to go 16 for red, 16 for green, and 16 for blue, okay? Just know that if you go up in bits from 8, the next number up in this equation has to be 16. It can't be 10. And the reason is because the hardware can't understand things in bits. It gets it in bytes, right? And a byte is 8 bits put together. It's a chunk of 8 bits, right? There's a byte here, and then if you go to 10 bits, if you send it 10 bits of information, you can't fit 10 bits in a byte. But you can't send it a fractional byte. You have to send it a full another byte, so it's got to get 8 plus 8, so that becomes 16. So if you go 10-bit or 12-bit or 14-bit, something like that, then you have to then use 16 for each color for the equation on the next one. So you can run, a normal 60 hertz, but as you go up in the bit rate, you then have to cut your load capacity per port in half. So I hope this was helpful in learning about load capacity per port on the controller and what that means and why it matters. If you have any questions, give us a call or visit our website.